what is quantum computing? Now, I keep hearing about this. It's one of the big breakthroughs in computers is going to be quantum computing.
Right. I'm almost the right guy. I'm not completely the right guy.
Right.
I actually did teach a course at Caltech that involved quantum computing, so I'm above average.
Definitely the best guy I've ever met.
But yeah. So quantum mechanics. This is the book that I'm writing right now. That's going to be out a year from now, called Something Deeply Hidden. It'll be about quantum mechanics, and the goal of the book will be to make quantum mechanics understandable to everybody and convince them that quantum mechanics really does imply the existence of multiple worlds where things look very much the same, except for tiny differences. And one way of thinking about what quantum mechanics says is in classical mechanics, which is what came before quantum mechanics, let's imagine you have a bit, right? That is something is either 0 or 1, right? One piece of information. In quantum mechanics, you have a quantum bit, a qubit, as they call it. Very clever. So the difference is that instead of it being a 0 or a 1, like it would be classically, quantum mechanically, it is in some superposition of 0 and 1. It's some combination of a little bit 0, a little bit 1. And it's not that you don't know which one it is. It's that it really is both. It might be 90% 0 and 10% 1 or something like that. So take that fact, number one, okay? Fact number two is that quantum mechanics has a thing called entanglement, which means that if you have 2 bits, classically, so you have 0, 0, 0, 1, 1, 0, 1, 1, right? 4 different possibilities. So quantum mechanics says it's not that this one bit is in a combination of 0 and 1, and this other bit is also in a combination of 0 and 1. It's that the 2-bit system is in a combination of 0, 0, 0, 1, 1, 0, 1, 1, right? So it might be that it's 50% 0, 0 and 50% 1, 1. So you don't know what either bit is, but you know they're the same, right? Okay. So that's entanglement. So you take these two ideas, that you have a combination of zeros and ones rather than just one or the other, and the different bits can be entangled with each other. And then you just say, well, what is a computer? A computer is something that takes bits in, does manipulations, and spits out the answer, right? You solve problems. That's what's literally going on in your computer. There's a bunch of zeros and ones being pushed around. So a quantum computer is pushing around a bunch of qubits, right? A bunch of spinning particles or something like that. The spin of a particle that can either be spinning clockwise or counterclockwise is a qubit. And so these particles can interact with each other. They can become entangled, and you invent a quantum algorithm, right? Like there's algorithms for, finding the area of a surface or something like that. Factoring large numbers, solving the shortest distance between two different points. You can do this using the rules of quantum mechanics instead of the rules of classical mechanics. And the belief, which is not yet 100% established, but we think is true, is that there are some problems that are really, really hard to solve for a classical computer, which means that you can easily make the problem long enough that it would take the lifetime of the universe to solve it on a classical computer, which quantum computers can solve quite quickly and efficiently. And so we haven't proven that. It's not a mathematically precise
Why would they think that quantum computers would be able to solve it quicker?
There's more information in the quantum computer. Like if you have 2 bits, 0, 0, 0, 1, et cetera, there's only 4 things it can be, right? If you have a quantum computer, there's an infinite number of things it can be because it's any combination of those 4 things, right? 10% this, 20% that. So there's like a continuum of possibilities. It's analog rather than digital in some sense. And so what you can do, the quantum computer can just sort of take advantage of that extra power to look. I mean, because of this entanglement, this is I'm going to get in trouble with my quantum computing friends because it's not quite fair. But roughly speaking, rather than manipulating bit by bit, because of the entanglement between the bits, the quantum computer can move all the bits a little bit at once. So let's say that you're searching for something in a list, right? A very elementary computer science program is I'm giving you a list, find an element that is equal to a certain number, right? It sounds easy, but if that list is 10 trillion things long, that's hard, right? So what the quantum computer can do is say, take every element in the list, nudge it a little bit towards 0 if it's the wrong answer and towards 1 if it's the right answer. And you don't know where it is in the list, but you can do that nudging over and over again. And at the end of the day, you look for where's the 1, and it's very easy to find. So you can get the answer much quicker, it is believed. And so things like cryptography, privacy, right, are dramatically changed by this, because one of the things that we think quantum computers should be able to do faster is factor large numbers, which is the The difficulty in factoring large numbers is the basis for much modern cryptography. But also simulating systems that were just too difficult to simulate. Just it took too much computer power to do it. Now maybe we can do it because nature is truly quantum mechanical at the core. It turns out to be very hard because the problem is you have all these bits. If you touch one of them, if the outside world bumps into one of them, right, like a cosmic ray or an atom hits it, the whole entanglement is ruined between everything. So it's very, very delicate. And that's what right now they're working on systems of, let's say, dozens of qubits entangled at once. You would like it to be way more than that because you can store an enormous amount of information in these things. And if it works, I think it'll be way better at computing if it works. I'm not at all sure that quantum computers will be efficient or cost effective or anything like that in the near term. But, doing computations faster is something that a lot of people want to be able to do.